Welcome. In this video, we're going to be looking at Lesson 5 from Module 1 for Grade 6. In Lesson 5, we're going to practice solving problems by finding equivalent ratios, and we're going to do it with tape diagrams. Now, you don't have to use a tape diagram, but in this lesson, that's the way we're going to do it, so you get some practice with it. In the first example, a county superintendent of highways, that's someone who's in charge of all the highways in the county, is interested in the numbers of different types of vehicles that regularly travel within his county. In the month of August, a total of 192 registrations were purchased for passenger cars and pickup trucks in the local Department of Motor Vehicles, the DMV. So that means 192 people purchased registrations for their cars or trucks. The DMV reported that in the month of August, for every 5 passenger cars registered, there were 7 pickup trucks registered. And we want to know how many of each type of vehicle were registered in the county in the month of August. Well, if we look at this, we know that for every 5 passenger cars registered, there were 7 pickup trucks registered. So that's our ratio. For Part A, we're going to write 4 different ratios and describe the meaning of each. So here's our first ratio. The ratio of cars to trucks is 5 to 7, and that is a part-to-part ratio. 5 and 7 are both part of the whole amount of vehicles. So 5 is a part and 7 is a part. It's a part-to-part ratio. Another ratio we could say was the ratio of trucks to cars is 7 to 5, and that is also a part-to-part ratio. Part of the total vehicles was 7 trucks, part of the total vehicles was 5 cars. Another ratio, the ratio of cars to total vehicles, is 5 to 12. We got the 12 from adding 5 and 7. The 12 is the whole. The total number of vehicles includes cars and trucks. So this is called a part-to-whole ratio. The ratio of trucks to total vehicles is 7 to 12. There are 7 trucks for every 12 total vehicles. This is a part-to-whole ratio. So I've got 4 different ratios. 2 of them are part-to-part ratios, and 2 of them are part-to-whole ratios. Let's take a look at Part B. We want to make a tape diagram that represents the quantities in the part-to-part ratios you wrote. Well, if you remember, we wrote 7 trucks to 5 cars. And so we're going to draw a tape diagram that represents those 2 quantities. The quantities are the numbers. So the number of trucks was 7, so we make 7 boxes. The number of boxes we draw is always equal to the number in our ratio. And then for cars, we're going to make 5 boxes. Since it was 7 to 5 trucks to cars, we should have 7 boxes and 5 boxes. You also want to make sure you always label your tape diagram so you know what the boxes represent. Part C asks, how many equal-sized parts does the tape diagram consist of? If we add 7 and 5, there are a total of 12 equal-sized parts, 5 for the cars and 7 for the trucks. That's where we got our total in our part-to-whole ratios in Part A. Part D asks, what total quantity does the tape diagram represent? Well, if we look back at our problem, the tape diagram represents a total of 192 registrations for both cars and trucks purchased in the month of August. So the whole tape diagram, all 12 of these boxes, represent a total of 192. If we look at Part E and go back to our original problem here, you can see where the total of 192 registrations were purchased for passenger cars and pickup trucks. We want to find what value does each individual part of the tape diagram represent. If we look, there are a total of 12 boxes and a total of 192 vehicle registrations. We're going to divide 192 by 12 to find the value of each individual part of the tape diagram. 192 divided by 12 is 16. This means each box represents 16 vehicles. If we want to find out how many of each type of vehicle were registered in August, I'm going to go back to my tape diagram, and I'm going to put 16 in each of the boxes. Since each of these boxes represents the same amount, 16 goes in each box. I got that 16 from dividing the total number of vehicles by the total number of boxes. To find the number of trucks, I'm going to multiply 16 times the 7 boxes here, which is 112 trucks. To find the number of cars, I'm going to multiply the 16 by the 5 boxes to get 80 cars. The steps we went through here are the steps that you're going to follow when we work on our exercises in class. So remember to go back to this example when doing each problem to see what steps you need to take. Let's do another example. In this example, there's one little difference that I'm going to talk to you about. Here, in example 2, the superintendent of highways is further interested in the number of commercial vehicles that frequently use the county's highways. A commercial vehicle would be a vehicle that's owned by a business instead of a person. He obtains information from the Department of Motor Vehicles for the month of September and finds that every 14 non-commercial vehicles, there were 5 commercial vehicles. If there were 108 more non-commercial vehicles than commercial vehicles, that's going to be an important sentence. 108 more non-commercial vehicles than commercial vehicles. That doesn't mean there were 108 non-commercial vehicles. It means that there were that many more, and we'll talk about it later. We want to find out how many of each type of vehicle frequently use the county's highway during the month of September. So we're going to look at the ratio. For every 14 non-commercial vehicles, there were 5 commercial vehicles. That's our ratio. 14 non-commercial vehicles to 5 commercial vehicles. We're going to first write the ratio. 14 non-commercial vehicles for every 5 commercial vehicles. Now we're going to draw the tape diagram. For the non-commercial vehicles, we need 14 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 boxes. For the commercial vehicles, we're going to need 5 boxes. Next, we have to figure out how we're going to find out what number to put in each box. We don't know the total number of non-commercial. We don't know the total number of commercial. And we don't know the total altogether. All we know is that if there were 108 more non-commercial vehicles than commercial vehicles, well, if there are 108 more non-commercial vehicles than commercial vehicles, if we subtract those two, we'll find out how many more boxes there were. Right? We're going to do that with a tape diagram. 14 non-commercial minus 5 commercial. That means there are 9 more boxes for non-commercial than commercial. These 9 boxes represent the 108 more non-commercial vehicles. See how it's sticking out past commercial? When it says how many more, right, that's a good time to know to subtract. And you can see visually that the more part is sticking out past the part that sticks out. So when we have these 9 boxes, to figure out how much goes in each of the boxes, that means we need to divide 108 by 9. So each box represents 12 vehicles. I'm going to put a 12 in each box for non-commercial and commercial. And then to find out how many of each type of vehicle, I'm going to multiply the number of boxes by the value of each box. For non-commercial, I have 14 boxes. So 14 times 12 is 168 non-commercial vehicles. For commercial vehicles, I have 5 boxes, so 5 times 12 is 60 commercial vehicles. Now, the steps are the same. Write our ratio, draw a tape diagram, and then figure out what goes in each box. Sometimes you have the total, like in our first example. Sometimes you know how many of one or the other. And sometimes you know how many more. That's what happened in this case. We knew how many more. And then the last step, once we find the number in each box, is to multiply the number of boxes by the value of each box to get the total. All right. Make sure you have your notes for example 1 and example 2 all written out. We're going to be working on our exercises when we get to class. See you then.